Welcome to the IM2 video lecture on the transformation of the quadratic function part 1. The learning target for today is for you to understand the vertex form of a parabola. Your 3 success criteria: 1. You should be able to find the characteristics of a parabola from vertex form. 2. You should be able to describe how the a coefficient affects the parabola shape. And 3. Describe how the h and k values affect the parabola shape. To start this off, we are going to explore these two functions. The question asks, how are these two functions the same or are they different? So let's start by graphing these two. So we have f of x is equal to x squared plus 2x minus 3. It looks like that. I have it in Desmos right here. Then I have g of x. G of x is equal to parentheses x plus 1 squared minus 4. Okay, good. Wow, they look exactly the same. So to motivate this idea a little bit further, I have this question to ask you. What is the vertex of each of the functions? Well, the vertex is defined to the location in which the parabola changes directions. So for a, it's right here. F of x's vertex is -1, -4. For g of x, it's the same here at -1, -4. Let's do what I notice and what I wonder. I notice that these two shapes look exactly the same. They even have the same vertex. I wonder, why are they the same, even though the two functions here look completely different? This has an x squared plus 2x minus 3, while the other one has x plus 1 squared minus 4. This leads us to our core concept of the vertex form. What you have here, f of x is equal to x squared plus 2x minus 3, is in the format of the standard form of ax squared plus bx plus c. This is something that you see in the prior units. Next, we introduce this new format, the g of x, which is the x plus 1 squared minus 4. This is actually in vertex form. We saw that these two are exactly the same parabola. They're essentially the same quadratic function. However, one is in standard form and the other is in vertex form. Why should you care about the vertex form? The vertex form has these 3 notes. 1, the vertex form is useful in finding the vertex very easily. In this case, the vertex here was -1, -4. There's this 1 here and there's this 4 here. That should help us with that. 2, the vertex form is useful in determining how a parabola transforms or moves about. And 3, the vertex form is actually not useful when determining the x-intercept. So to check this, we are going to do the core concept check here by, for you, graphing these 4 functions. Let's do that. You're asked to find the vertex if it's a minimum or maximum. 2 is to find the line of symmetry. Afterwards, you're going to find the x-intercept, then the y-intercept for all the following functions. Give that a try. All these, you have to put it into Desmos. Number 1 looks like that. You have here your 0, 0, which is the vertex, which is also the minimum. The line of symmetry goes straight down here, which is going to be x is equal to 0, because that's where it splits it in half. The x-intercept is where it crosses the x-axis right here at 0, 0. And the y-axis is right here, and it crosses it at 0, 0. This is considered to be the parent function. All parabolas can be written from the parent function of x squared. Let's look at the second one. So the second one, graphs like that. The value of the vertex is 0, 0. It is now the maximum because here it is the highest point now. Okay, The line of symmetry is still the same, as well as the x-intercepts and the y-intercept. 3 is when we moved it to the right somehow. It has a new vertex, but it is still maximum at 3, 0. The line of symmetry is new here as well at x is equal to 3. The x-intercept is the same at 3, 0, like the vertex. The y-intercept is right here at 0, -3. 4 looks like that. Wow, this moved it up. Here, the maximum is now 3, 5. Line of symmetry goes straight down here at x equals to 3, goes all the way down here, crosses the x, it has to be straight, the x-intercept at, so the x-intercepts are right here. Okay, and those are a little bit off in terms of it. They're not whole numbers. Okay, so the x-intercepts here are these weird decimals. I approximate it. And the y-intercept is right here at 0, 2. So let's take a look. So let's look at number 1 and number 2. Something that you should notice and something that you should wonder is, how did the blue come about from the red? Looks the same. And you should wonder why it does that way. So we're going to look at the vertex form that we introduced today. The vertex form can be written from number 1 and number 2. All I did is I subtracted 0 from the x to show the h and a plus 0 for the k. They're there, but no one writes the 0. Same thing for the g of x. So the question here is, what is the value of a for each of the functions? So f of x, a is equal to 1, because that's where it is right here. And the a here for g of x is -1/3. So how did that a value affect this function? Well, that negative will actually flip the parabola. That is why this is positive. It opens up, but this was negative and it opens down. That fraction, 1/3, changes the size of the parabola. Notice that the blue is slightly bigger or wider than the red, f of x. So this leads us up to our core concept that was introduced in the prior lesson, but it holds true for the vertex form as well. When a is positive, it opens upwards. When a is negative, it opens downwards. That a, the sign of a affects the reflection. Up or down. The value of a, right, or the magnitude of a, the value of a affects the size, or you could say it dilates the parabola. So these are your 4 problems, and you're going to compare it to the f of x equals to x squared. You're going to see how it opens. Right? Let's take a look. So the first one, we know that the f of x is x squared. That's how it looks like. That's the parent function. So the first one, g of x, we know that this is parentheses x plus 2 squared plus 5. Wow. So that's open upwards, and it looks like it's the same shape as well. So let's see. So it does open up because the a here is positive, and the size does not change because the a is equal to 1. Next, we see it's negative 1/2. Well, this one, we would say that a is negative, so it should open what? Down. And we would saw that the a here is a fraction in between 1 and 0, so it should get wider. Let's take a look when we graph it to see if our answer is valid. Negative 1/2 x plus, minus 4 to power 2 minus 4. Right? Yep, it went down and it got, did it get narrower or did it get wider? It got wider, so yep, that is correct. So next we have a is equal to negative 2, so that should open down because a is negative. And we saw that a here is bigger than 1, so it should get narrower. Okay. Let's see if that is valid when we graph it to double check. Negative 2 x plus 2 to the power of 2. Oh, yes, it did open down, and the graph did get taller. It got compressed. And the last one, we know that the a is positive, so it should open up. And we know that a here is bigger than 1, so it should get taller, or we can say it got narrower. Let's double check in decimals. 3 parentheses x plus 5 squared plus 1. Perfect. Good. Now let's take a look at the exploration of how h and k affects this. So I wrote number 2 and number 4 in vertex form, showing the h and the k. So the question is this: what do you notice and what do you wonder? Well, I notice that these two parabolas are at different locations. What I wonder is, why are they at different locations? And how can we tell? So we'll start off with the question of what is the h and what is the k for each function. The h is right here, exactly like what vertex form gives you. H is equal to 0 for g of x, and the k here is equal to 0 for g of x. For g of x, the h here is the 3, and the k here is the 5. So the question is this: how did the h and the k affect the function? Well, let's just put the vertex here first. The vertex for the g of x was 0, 0. The vertex for the j of x was 3, 5. Notice that here you went to the right 3 times, right 3, then you went up 5. Wow, that is interesting. How did the right 3 appeared? That's your h, right? H is equal to 3. How did the h5 appear? That's your k. K equals to 5. So, what does h control? Well, h controls how much you move to the right or to the left. What does the k control? The k control how much you move up or down. This leads us up to our core concept that we just discovered. The vertex h and k, the best part here is that h can tell us how much we move in the horizontal direction, which means left and right, and the k tells us how much we're going up or down. So what I have here is the k. When k equals to 0, it's the parent function, which is in blue. When we have positive k, it moves up, and when you have negative k, it moves down. This is your vertical shift up and down vertically. Your h controls your horizontal, left or right. The parent function here is in blue when h equals to 0. When you minus h, it gets smaller, so you're going to move to the left. And when you add h, it moves to the right. Here's your practice problem. These 4 problems were already given to you, and you're going to tell us how it moved based on the parent function. Okay. We should see that you can look at the vertex and tells us how it's going to move. Like the first one. Well, that's right. So this was the first one. We saw that it went from 0, 0 all the way here to this value. Okay, whoop. Okay. Let me just cross that out right there, that dot. It goes all the way to negative 2 comma 5. Okay. How we go about that from our original to here is we move to the left 2 times, then we went up. So we can take a look. The vertex here is negative 2 comma 5. That 2 was our negative, so we went to the left twice. Then the 5 means we went up 5. So we can do it here as well. Okay. Here we saw that the h is your 4, so this should be a 4, and your k should be negative 4. It's a positive 4, so we went right 4. Then it's a negative 4, so we went down 4. Okay, let's see if that worked. Let's graph that. Negative 1/2 x minus 4 squared minus 4. That is correct. Notice, was our analysis correct? Yes, because we went to the right 4, then we went, notice you went right 4, then we went down 4, exactly like that said. Good. Next one, let's take a look. Here it's a plus 2. Remember, in vertex form it has to be minus h. Okay, so the h here is going to be a minus 2. And the k here, you don't see it, but it's a 0. The minus 2 means left 2, and the 0 means that's it. You just went to left 2. Let's see if that works. Let's graph that. Negative 2 parentheses x plus 2 squared. Let's see if that worked. Yes. So our original was 0, 0, and we moved to the left negative 2. Okay. So that's why that vertex is negative 2. Okay. There you go. Let's see if we did it correctly by double checking our answers. Good. The next one, our vertex is negative 5 comma 1. We means to the left 5 and up 1. Let's graph that to double check our work. 3 parentheses x plus 5 squared plus 1. Let's see where it is. There it is. We went left 5, then up 1. So there you go. So the h and the k affects the translation of the parabola. It tells us where we're moving. H tells us where we're going left and right, and the k tells us where we're going up or down. There you go. Those are your transformations of a parabola.